Welcome to another deep dive with us. This time, we're going to be tackling something uh, I think pretty fascinating.
Yeah.
Quantum entanglement. We've got a great essay here by German
Oh,
physicist
cool.
Jorgo Schneeppert.
Okay.
It's called Verschränkung, entangled by Schuh der Quantenverbindung, which I think is pretty cool.
Yeah.
The mystery of the quantum connection. But don't worry, we're
Right.
going to be breaking it down in English for you.
Yeah.
So imagine particles influencing each other like instantly across huge distances. Sounds crazy, right?
Yeah.
It's entanglement, though. And it really makes you kind of rethink what reality even is.
Mm,
Luckily, we've got an expert here to help us kind of wrap our heads around this stuff.
I'll do my best.
So where do we even begin with something like quantum entanglement? It just seems so bizarre.
Well, I think, like Jorgo Schneeppert points out in the essay, to get entanglement, you got to kind of first revisit this idea of superposition. And maybe think of it this way. Imagine a particle that's existing in like multiple states at the same time. Like a spinning coin that's both heads and tails
Yeah.
until you stop it.
Yeah.
So that's superposition.
Okay, yeah, I think I'm with you. But how does that then connect to entanglement?
So entanglement takes that idea of superposition and it's like it goes a step further.
Okay.
Instead of just one particle being in multiple states, entanglement, it involves two or more particles and they get linked together
Uh-huh.
in a shared state,
Right.
no matter how far apart they are. So their fates are intertwined, even across like vast distances.
Okay, so let me see if I got this right. If I measure the state of one of these entangled particles here on Earth, I instantly know the state of its partner, even if it's way out there in space.
Yeah, exactly. And that's like what baffled, some of the greatest minds in physics, like even Einstein.
Oh, wow.
So back in the 1930s, Einstein got together with these physicists, Podolsky and Rosen, and they proposed this thing called the EPR paradox. And they were basically arguing that the implications of entanglement were just so wild
Yeah.
that it had to mean there was something wrong with quantum mechanics. They just couldn't accept that, like, measuring one particle
Right.
could instantly affect another one that was far away.
Right.
Einstein even called it spooky action at a distance.
Spooky action at a distance. I like that.
Yeah.
Yeah, it does sound kind of spooky when you put it like that.
Okay.
But if Einstein and those guys were skeptical, how did we then come to accept entanglement as this real phenomenon?
Yeah, so Schneeppert actually talks about this pivotal moment in the history of entanglement.
Ah.
It all comes down to Bell's theorem and these experiments by Elaine Aspect.
Okay.
So Bell's theorem basically gave us a way to test whether these spooky correlations that entanglement was predicting were real
Yeah.
or just like some quirk in the way we were understanding things.
Okay.
And then Aspect comes along in the 1980s with these experiments.
Yeah.
And those experiments were some of the most convincing evidence for Bell's theorem. So they confirmed that, yeah, entanglement's actually a real thing. It's a genuine feature of the quantum world.
Okay, so we know it's real, no matter how bizarre it seems.
Hmm.
But how does it happen? Like, how do you create entangled particles in the first place?
Yeah, so Schneeppert describes this process called spontaneous parametric downconversion.
Okay.
So you can imagine like shining a laser through this special crystal
Right.
that splits the light into these two twin beams. But these twins are not just ordinary light, they're entangled photons.
Oh, wow.
And they're linked in a way that like our classical understanding of physics just can't explain.
So it's like the crystal gives these photons this like interconnected quality
Yeah, it's wild, right?
that we can actually like create entanglement.
Yeah.
That's incredible.
Hmm.
But I have to ask, why should we even care about these entangled particles?
Hmm.
Like, what's the big deal?
Okay, so that's where it gets really, really exciting. So Jorgo Schneeppert highlights three main areas where entanglement has the potential to revolutionize, technology.
Oh, okay.
Quantum computers, secure communications, and even, get this, teleportation.
Wait a minute. Teleportation, like beaming people up like Star Trek.
Not quite. Schneeppert's really careful to clarify that he's talking about quantum teleportation.
Yes.
And that focuses on transferring information, not actual matter.
Okay.
But imagine, right, you could transfer the entire quantum state of a particle to another particle, no matter how far apart they are.
Right.
And you're not even physically moving the particle itself. That's the potential power of entanglement.
That is amazing. We just started talking about entanglement, and it's already changing how we think about what's possible. But before we get into like the applications,
Yeah.
I want to know more about like why this concept is so groundbreaking? Like, why does entanglement shake the foundations of how we understand reality?
That's where we start getting into like philosophy.
Oh, cool.
Entanglement, it like directly challenges this everyday notion that we have of locality.
Okay.
This idea that things can only be influenced by like their immediate surroundings.
Right, right.
If two particles can act as one across huge distances, then that suggests a much deeper connection in the universe
Yeah.
than we ever imagined.
So are we saying there's like this invisible thread connecting everything?
That's a good question. It's a question that physicists and philosophers are still trying to figure out.
Yeah.
Entanglement seems to be telling us that the universe might be way more holistic and interconnected than our like classical worldview allows us to understand.
Yeah.
It pushes us to rethink some of our most basic assumptions about what reality even is.
That's pretty deep.
Yeah.
So far, we've gone from like the definition of entanglement and how it's created to these huge philosophical questions that it raises
Yeah.
about reality itself. But I'm definitely interested in learning more about those practical applications.
Well, we're going to dig into all those details in the next part of our deep dive.
Awesome. I'm really excited to get into that. Welcome back to our exploration of quantum entanglement. Last time we talked about, entanglement being a real thing,
Mm-hmm.
even though it seems kind of impossible. And we even touched on how they create entanglement in the lab using those crystals.
Mm.
But Schneeppert, he doesn't stop there. He goes deeper into this thing called the measurement problem.
Oh, yeah. The measurement problem. That's a good one.
Yeah, it sounds pretty intimidating. Can you break it down? What's so problematic about measurement in quantum mechanics?
Well, so we've been talking about, quantum particles existing in this hazy state of superposition
Right.
until they're measured.
Right.
But the act of actually measuring them, it seems to like force them to choose a definite state. And so the measurement problem is basically like, okay, well, what actually counts as a measurement? And does us observing something, does that change reality?
Wow, that's a pretty deep question. Like, is saying that reality isn't objective, but it's somehow influenced by our consciousness. Did Schneeppert offer any insights into that?
He did. Schneeppert uses, that classic thought experiment, Schrodinger's cat,
Oh, yeah.
to kind of illustrate the paradox of superposition and measurement. The
Yeah.
whole, cat in a box, both alive and dead until you open it.
Right, I've heard of that one. But how does a cat in a box help us understand entanglement?
It's not really about the cat.
Okay.
It's about this idea that the cat's fate, whether it's alive or dead, it's like uncertain until we look at it.
Right.
Schrodinger's cat is just a good way to kind of picture the way that quantum particles seem to exist in multiple states until the act of measuring forces them to pick one.
So are we saying that reality is fuzzy or undefined until we observe it and make it concrete?
That's one way to look at it. And it's an idea that's, been talked about by physicists who kind of follow this Copenhagen interpretation of quantum mechanics. They're suggesting that observation actually plays a role in collapsing this thing called the wave function, which is, just a mathematical description of all the possible states a particle can be in.
Okay, I need a little more on that one. What is a wave function?
Think of it like a map of all these potential realities that a particle could have. And when we measure it,
Okay.
we're basically choosing one of those realities to become real.
Right.
And the wave function collapses, and we're only left with the outcome we observed.
So before we measure it, the particle is kind of just floating around in this cloud of possibilities.
Yeah.
And then our observation, it's like, boom.
Exactly. It forces it to be a definite state. But Schneeppert also points out that there are other interpretations of quantum mechanics, too,
Okay.
that, offer other explanations, like, for example, the many worlds interpretation.
Oh, okay.
Which suggests that all the possible outcomes of a measurement actually do occur,
Yeah.
just in different, like, parallel universes.
Whoa, parallel universes. Now that's getting a little sci-fi.
It is mind-bending. But the point is that entanglement, it really forces us to think about these possibilities that are way beyond our everyday experience,
Mm-hmm.
It forces us to confront, the limitations of our classical worldview and embrace new ways of thinking about what reality is.
It's fascinating and maybe a little scary to think that observation could be shaping reality, or that maybe there are other versions of ourselves out there living different lives. Did Schneeppert have a favorite interpretation?
Not really. Yorgo Schneppet does a great job of laying out all these different interpretations without picking sides. It's up to the reader to kind of, figure out what they think about the implications. And there are a lot of them, touching on things like, consciousness and free will and even just the meaning of existence.
That's incredible that something as abstract as entanglement can lead us to think about these things.
Right.
But I feel like we're just scratching the surface here.
Yeah, definitely. We've explored, entanglement itself, and we've kind of delved into this measurement problem.
Right.
But when we come back, we'll switch gears and look at the potential of entanglement to completely change technology.
Okay.
From unhackable communication to super powerful computers, entanglement's future is bright.
That's pretty exciting. I'm really looking forward to learning more about those applications. Welcome back to our deep dive on quantum entanglement. We've talked about how mind-boggling it is and all the philosophical questions it brings up, but now I think it's time to get practical. Schneppet ends his essay by talking about the potential of entanglement to totally revolutionize technology. So let's start with the big one, quantum computers.
Oh.
Schneppet seemed pretty excited about this one.
Yeah, and for good reason. Quantum computers could solve problems that would take, our normal computers billions of years. They could change everything. Medicine, material science, artificial intelligence, anything that needs a ton of computing power.
That sounds amazing. But I gotta be honest, I'm still not sure I really understand how they work. What makes them so different from the computers we use every day?
It's all about how they process information. Regular computers, they use bits,
Right.
which can be either 0 or 1. But quantum computers, they use qubits. And because of superposition, those qubits can be 0, 1, or both at the same time. It's like having a computer that can look at every possible solution to a problem all at once instead of one at a time. That's the power of quantum computing, using superposition to be super fast.
Okay. I think I'm starting to get it. But so where does entanglement come in? How does it make quantum computers even better?
Entanglement lets us connect those qubits together in a way that makes them super correlated. It's like this, you entangle two qubits. They're both still in that superposition of 0 and 1, but now they're linked. If you measure 1 and it's 0, you automatically know the other one's a 1, even if they're far apart. This lets quantum computers do these huge parallel calculations that regular computers just can't do.
So entanglement's like the secret ingredient that makes quantum computing really take off. Schneppet also mentions secure communication as another cool application too.
Right. Entanglement's like the key to making encryption that's basically unbreakable
Wow.
through something called quantum key distribution.
Okay, quantum key distribution. How does that work? What makes it so much safer than the encryption we use now?
Imagine using entangled particles to create those encryption keys.
Okay.
And those keys are shared between two people. The awesome thing about QKD is that if anyone tries to listen in or mess with that key exchange, it'll change those entangled particles. And both people will know someone's trying to spy. It's like a built-in alarm system.
So you can't steal the key without getting caught because you'd mess up those particles.
Exactly. This could change everything. Online banking, military communications, all kinds of stuff. Because then you'd know your information is really private. And that's not all. Remember quantum teleportation?
Oh yeah. Transferring information, not matter.
Yeah.
It still sounds kind of like science fiction.
Yeah.
When-
Schneppet points out that we're still in the early stages of figuring it out. But the possibility of sending quantum states across huge distances could lead to these, mega powerful quantum networks.
It's wild to think that entanglement, which seems so weird, could actually have these huge real-world impacts.
Definitely. Yorgo Schneppet's essay is a great example of how entanglement is going from just a theory to something that could change the world.
Yeah. We've covered a lot of ground in this deep dive into entanglement. From just defining what it is to thinking about all the crazy philosophical stuff.
Right.
And now to how it could change technology forever. If you're interested in learning more, I highly recommend reading Schneppet's essay. It's a great read. But for now, we'll leave you with this thought. As we keep figuring out entanglement, we're not just inventing new technologies, we're pushing the limits of what humans can know and what's possible in the universe. Thanks for joining us.